Hi, this is Pradeep Nalimalli from Xilinx DCG networking team. Welcome to the OVS demo on our SmartNIC. Let's dive in and check details of what our U25 offers and the details of the current demo. I would like to start by stating that there is a networking crisis in the data center, and everyone is aware that networking traffic is growing very rapidly in and out of the data center. Also, the data suggests that the traffic inside the data center, which is east-west traffic, growing together at 25% compound annual growth. What's not as obvious is what does this traffic growth mean in terms of cloud data servers. What we are finding in the cloud data centers is with the rise of SDN, they implement a lot of the software-defined networking functions in software running on CPU cores. As that network traffic explodes, it's driving extra work into cloud data center, and this work is not application processing. It's just moving packets in and out and processing them. So what is happening is, this is eating up the CPU resources and taking a good chunk of the CPU processing power away from applications that usually CSPs use for their business activities. Or in the case of public cloud, they would be monetizing those resources by selling application instances to their customers. As you see from the chart in the far right, the vast majority of networks, more than 80% of cloud servers, still do not have SmartNICs. They have traditional NICs and they continue to run their networking functions in software. Many smaller cloud service providers, particularly Tier 2 and Tier 3, don't have large R&D teams and resources to develop and deploy their own solutions. So they really need to have solutions much more readily usable out of the box with standard APIs that they can just plug in and leverage the benefits of offload without having to develop these solutions themselves. Xilinx recently announced the Alveo U25 is what we are calling the first hardware instantiation of our SmartNIC platform. Why do we call it the first comprehensive SmartNIC platform? Because unlike previous solutions that may have come out and focused singularly on perhaps networking or storage, this solution blends networking and storage and also now compute acceleration onto a single platform. From that perspective, this is the first platform we believe that provides network, storage, and compute offloaded acceleration on a single card. Also, it's fully adaptable, supporting user-level programmability of the FPGA features. Our Vitis Unified Development Environment is free to download from Xilinx website. Vitis Unified Software Platform includes an extensive set of open source, performance-optimized libraries that offer out-of-the-box acceleration with minimal to zero code changes to your existing applications. But in addition to that, on U25 SmartNIC, we will be offering a range of turnkey accelerated solutions which are pervasive in enterprise and data center networking. The Alveo U25 is a comprehensive SmartNIC platform from Xilinx. Unlike previous solutions that may have come out and focused singularly on perhaps networking or storage, this solution blends networking and storage and also now compute acceleration onto a single platform. The U25 is on Xilinx FPGA technology. It is fully adaptable and programmable, supporting user-level programmability of the FPGA features. This adapter supports two 25GB Ethernet ports via SFP28 cages. The adapter comes in a half-height, half-length card form factor. It's a very compact form factor that will fit in any 1U cloud server and supports PCIe Gen 3x8 up to the host in CPU. This SmartNIC also supports all the baseline NIC features out of the box. All standard offloads like tunneling offloads, checksums, TCP segment offload, receive side scaling, SRIOV, word IO are supported. The Ethernet drivers are standard and upstream with various flavors of Linux disties. We also support the onload technology on our X2 NICs. The onload technology allows you to take advantage of low latency through a kernel bypass technique that SolarFlare developed and pioneered in the fintech industry over the past 15 years. We have benchmarks that show up to 400% improvement in the application performance just by using onload. Additionally, this adapter supports timestamping and storage processing. The FPGA on the card is a Zinc class device having over 500,000 LUTs and also an embedded quad A53 processor complex, which can be used for things like control plane processing, for example. Also on the board is 6 GB of DDR4 SDRAM, which can be used for things like packet buffering or table expansion for the lookup tables and other functions. Also, this card supports all the standard operating systems and also a standard manageability and boot features. The current OVS reference design on U25 has been validated between the network VM, VM to VM, and network to network data paths. In all these three cases, first few packets of any unique flow has to be acknowledged by OVS running in the kernel or OVS DPDK in user space. Xilinx OVS also supports OVS kernel commands, tcflower, and OpenFlow APIs. An optional PCIe Gen 3x8 connection will allow you to connect the host and the FPGA direct. This can be utilized to do control plane traffic or any Vitis Vivado design flows. This is an obvious advantage for compute acceleration. Last but not the least, there is X2 sitting in our U25 SmartNIC, which complements the FPGA in providing the best-in-class networking solutions for the cloud, data center, and enterprise networking and computing space. This slide outlines the OVS performance of the current demo that we have measured using a single flow in the match action table. In fact, the numbers remain the same when we increase the number of flows to 7,000 on this POC. The block diagram shows the data path with traffic coming in from 100 gig port forward to the other port using the OVS fast path. The performance table lists the throughput as well as PPS for different packet sizes. This is demonstrated on a development vehicle of U25 which has 100 gig max designed on it. Production U25 has 25 gig max on it. The SmartNIC is processing close to 100 gig line rate without utilizing the CPU. Only OVS control plane runs on the host CPU. There is a lot of logic that is left over on the FPGA which can be used for accelerating other workloads such as IPsec, firewall, SSL TLS, or deep packet inspection. Let's quickly dive into the demo now. Welcome to the OVS reference demo on Xilinx FPGA SmartNIC. The hardware that we have used for this particular demo is development board of U25 which has 100 gig max on it. On the terminal you could see two rules that we have used for this demo. Traffic that is coming on MAC 0 will be redirected to MAC 1 and vice versa. These rules are added on the FPGA, so all the traffic that hits this rule will be fast path. With that, let's go into the packet generator. Let's start pumping traffic, starting with 1400 packet size. We are pumping traffic on port 1 and looking at the stats on port 0. We are pumping at 99% of the 100 gig bandwidth, so you could see close to 99 gigs. Let's also try to capture the number of packets that are received and the packets that are transferred. So we stop the traffic and look at the number of packets that are transmitted and the number of packets that are received on port 0. Let's do the same experiment on a different size of packet. In this case, let's pick 350 bytes. Let's start the traffic. In this case, we are pumping the traffic on stream port 1 and receiving the traffic on port 0. Observing the traffic on port 0 stats, we can clearly see the traffic bitrate at L1 is close to 99 gig. Let's also check the total number of packets on port 1 and port 0. This is just to make sure we don't have any loss of packets, which is very important. Now let's try to run the same experiment on the minimal size of the packet, in this case 68-byte packet. Traffic has been started on port 1 and being received on port 0. Small packet performance on a unidirectional setup looks to be 83 gig, and the packet rate is close to 118,000 packets per second. Let's also take a look at the packets on both TX and RX and the match. This confirms there is no traffic loss. That ends the demo. Let's wrap it up with one key takeaway slide. The key takeaways we want to demonstrate through this POC is that Xilinx SmartNIC OVS implementation is fully flexible and configurable with P4 programmable data path, and it supports full line rate of fastpath with no packet loss. Xilinx OVS reference design also supports TCFlower and OpenFlow APIs tested with Open Daylight Controller. There are other relevant network and compute offloads in the roadmap like firewall, IPsec gateway, TLS SSL, DPI on Alveo U25. Please reach out to Xilinx sales for more details and schedules.